again, George?
Me and Pat are playing with.
Very good. Okay, this is review for the benchmark 6, which is actually chapter 5 test. And it's about evaluating integrals and finding area between a graph or a curve and the x-axis using geometric formulas. So, the graph of f of x is shown below. The curve from 12 to 18 is a semicircle. Using geometric formulas, calculate each of the following. So for part A, find the integral from -6 to 4. So to find the integral from -6 to 4, we're going to evaluate the integral by finding the area of this triangle right here. So what's the base length on this triangle? Right, from -6 to 4 would be 10, right? 4 minus -6 is 10. So to get this triangle area, we do 1/2 base times height. So 1/2 times 10. The height would be this distance right here. So what's that? 5. Or now it's going to end up. We're going to end up with a negative integral because it's below the x-axis. So if you want to put the negative in right there, you can times -5. Just have to make sure you could use +5, but you have to make sure your integral is a negative number here because you're below the x-axis. So that's going to come out to -25. Any questions about that? All right, part B, integral from 4 to 12 of f of x dx. This time we're going to be looking at this trapezoid right here. So you can use the formula for the trapezoid if you want, which is 1/2 height times base 1 plus base 2. Or you could split this up into 2 triangles and a rectangle, which is how I'm going to do it. So this first triangle between 4 and 8, it's 4 wide and 5 high, so what's the area going to be? 10, right? 4 times 5 divided by 2 would be 10. And it's positive because we're above the x-axis, so the integral is going to be positive. Area is always positive, but integrals can be negative if they're below the x-axis. How about from 8 to 10? What's that area going to be right in here? Right, 2 times 5 would be 10. How about this little triangle over here? It's 2 wide and 5 high.
5.
Right, 2 times 5 divided by 2 is 5. So this total integral down here would be 10 plus 10 plus 5, 25. Any questions about that? All right. Letter C, integral from 12 to 18. So here we're looking at a semicircle. Told us that in the directions. So we need to think about the area of a circle. Find an area of a circle by doing pi r squared. Looks like the center of the circle would be about right there. What does it look like the radius of the circle would be? 3. Right. Go 3 this way, 3 this way, 3 this way. The radius is definitely 3. So the area is going to be, and it's only half of the circle, so we're going to take half of pi r squared. So half of pi times the radius, which is 3 squared. So that's going to be 9 times half times pi, so 4.5 pi, 9/2 pi, whatever you want to call it. I'm going to call it 9/2 pi. But you could also call it 4.5 pi if you wanted to. All right, the integral from -6 to 18. So now they want the total for letter D. This was, I'm going to change this to -4. Oh, I forgot the negative on it, didn't I? Because it's below the x-axis, don't forget that. So now if you want the integral of the entire thing, what would you do with these 3 answers? Add them together, right? So you'd go -25 plus 25 plus -9/2 pi, or -4.5 pi. The -25 and the positive 25 would cancel out. Final answer here, -4.5 pi. Those are my final answers on all these. Any questions about those? Okay, so integrals can be negative. Areas cannot be. Part E, find the area between the x-axis and the graph of f of x on the interval from -6 to 18. So if you're going to find the area between -6 and 18, what's the only thing you're going to do differently than you did in part D? All right, so you're going to count everything as positive. So that's 25 plus another 25 plus 4.5 pi. It's going to look like this, 25 plus 25 plus 4.5 pi. So ignore the negatives, in other words. Okay? We're not worried about where the area is at, we just want the total area between the graph and the x-axis. So that answer is going to end up being 25 plus 25, so it'd be 50 plus 4.5 pi. Any questions about that?